So in the previous video, we spoke about using exceptions and the method call stack and the streams. We have our system out stream, which is our sequence of bytes. And we have our standard output stream and our standard error stream, which is system.error as well. And then we also spoke a little bit about our basically out of scope, what happens when it goes out of scope. So in this now we have what's called using chained exceptions. So when I run this program, we have our main, then it calls method 1. So with our try, it goes to method 1, which is here. Then it tries method 2. Then it goes to method 2. Then it tries method 3. So it goes to method 3. So method 3 then executes because method 3 throws a new exception. And what happens here, which is really interesting, is because it has our throw new exception, and then the program flow of control then will go back to where it was invoked from. So where was method 3 invoked from? And it will go to the here, which is part of our outer try, which we spoke about in the previous video, and then it will go to the catch. This then has a throw new exception. This will execute. It will go back to where method 2 was called from and execute this catch. This will then go back to where method 1 was called from, which is all the way back up here, and then it will print our stack trace. So there in the older parts of Java, when it was previously, we didn't have a way really of being able to trace or chain certain exceptions like that. So the chained exceptions then enable an exception object then to maintain the complete stack trace information from the original exception. So you're able to get everything all together, and then it prints your stack trace. So if a catch block throws a new exception, the original exception's information and stack trace are lost. And that's important to remember from our data structures video, from our previous video we spoke about as well, from the using exceptions video, that we have our stack unwinding. So when we do our stack unwinding, then obviously every time that a catch is called within that block, then it's going to go out of scope with any local variables. And our program of control is important. There's also another thing that I want to talk about as well, which is part of Java Standard Edition 9, which we will come across later on, but it's called the Stack Walking API. And it's much more efficient way of walking through stacks. And you can use, it's a class called Stack Walker, and it's also part of the java.lang package because it's part of the standard edition Java Standard Edition 9. So we'll come to that later on though, because that will be part of lambdas and streams and stuff. So here, if I press play, you can see our java.lang exception thrown in method 1, then in method 2, then in method 3, and 2 more, and you can see that there's much more stuff. So here we have exception thrown in method 1, method 1 then main, and then caused method 2 from method 1, method 3 from method 2, and so on. So if we wanted to, what we could do is, for ease of use, have it as our print and just print out this is our try block in main. And then we can also output here before the stack trace. This is our stack trace in main. And we have here in method 1. This is a great way to kind of figure out the flow of control. You can put in multiple different lines like this where you'd have multiple different, so you could say this is our catch in method 1 before exception is thrown, and then we can have our catch in method 1 after exception is thrown, and you'll see now this won't execute, so because it throws an exception. But we'll take this and we will put it down here underneath method 3, and we'll also put it here so that you can see, and I'll just write down method 2 try, and maybe here we could say catch in method 2 before exception is thrown, and then we can also write it in here. It might be easier to see. Ooh. Undo, copy, might be easier to see. Just method 3. So just for you can see what happens. So you can see what happens. That it's quite funny because method 3 is already up here. So we have here our this is our stack trace in main, which is last. So as it goes along, we have our try and our catch, but we also have our flow of control. So our program flow of control is quite important with this, because you can see here it's catch in method 2 before exception, catch in method 1, and then this is in our main, which is our final thing that's called. So we have our 4 methods because we have our main and our 3 methods. That naming convention, again, I must reiterate, the naming convention in this is just for demonstration purposes. Do not use method 1, method 2, and method 3 when you're in the workplace or for an assignment or anything, because it's not a good naming convention. But just for demonstration, you can see it here. So we have main, method 1, method 2, and method 3, and then method 1 try block calls method 2. Then we have method 2's. So we have here, we just method 1 calls method 2, method 2 calls method 3, and then in method 3 then it throws a new exception, and because it doesn't have a try, because this just throws a new exception, it doesn't have a try associated with it, then the exception is returned to the calling method, which is method 2. So then this goes back to method 2 where it was called from, which is here, which is where we have our method 2 try. So then this obviously doesn't get executed because it's already, yeah. So then we have our this statement is in a try block, so this is part of a try block, and then the exception is caught between here and here. It's then caught, and then therefore the try block terminates and the exception is caught, and then it goes again. We call the exception with 2 constructors. So we have our E here of where it's called, so exception thrown in method 2, and it tells you here, and then we call the method with their 2 arguments. So with each of the exception, then exceptions with throwables, so our throwable method get cause can also be used, and that's for any chained exception. You can get a throwable that initially calls the exception. So then our output then shows our different stuff here. So we've exception thrown in method 1. So if I was to remove this, and it's really important to also play with your programs to see and figure out some of the things that you're doing. So if I removed then, let's say, exception thrown in method 2. So we have exception thrown in method 2 is written here with our output, and we'll just remove some of the system.out as well, because we don't need them really. That was just for demonstration of what you can do with figuring out your code and stuff. especially in the workplace. A lot of the things that you have to figure out, somebody else's code has been written, and they might have done something that's difficult to read, or in a rush, let's say, or like with a deadline. So as you can see, some of the where you put the system.out is important, because some of them aren't going to execute. So this is our try block in main won't, because it's already gone after method 1 is called. The stack is gone, it's out of scope, and then the try block executes. So we have here unnecessary system out. So here we can go again, and you can see here exception thrown in method 1, and you can see the different parts of what happens with it. If I was to remove this as well from here, it would look a lot simpler. So because we're calling, we're using the constructor with our with our exception in it, it looks a little bit different. So in our catch, so we have here our exception thrown in method 1, and then it just says method 1 and main, and it doesn't give as much information. So when you can call different constructors within exception, then you can see more detail. So here we have more detail regards what's happening. So we have exception thrown in method 1 using change exception, what line it's on. So I can go to line 18, there it is. Then it goes to line 6, which is main, where it's called from. Then it goes to method 2, which is down here, which it throws another exception. Then it goes to where method 2 is called from. Then there's another throw new exception, but there's no try block, so it goes back to where it was called, and so on and so forth. But there's one more, and there's two more here as well. So you can see that with the program flow control, it's important to know what goes where and what happens first. So it's also unnecessary to put in system.out printf statements when you have something like this that you can use as part of exception. So if I go to exception, then you can see, I bring it over here, exception.class, and you can see the different, it extends, as we know from inheritance, that it extends the family. So it extends from throwable, and that's your superclass. So here we have our exception. It takes from the throwable constructor as well. That's why we use super. And here it constructs a new exception just with the string message, but also that there's a throwable cause here, and there are multiple different constructors down the way as well. So you can go into more detail as you're using exception as well. And there's more information online as well with the Oracle website, but again, it's a case of figuring it out when you're in the workplace and figuring out what other people have written maybe, and other people have written some exceptions that are within the code itself, so they're not necessarily using this part. Yeah, so that's it for today. Thanks for watching. Please subscribe to my channel if you want to see more videos. I'll be happy to post more, and give it a thumbs up if you like it. Okay, thanks for watching. Bye.